Welcome to another video. Let's solve these cubic equations, but this equation looks so weird for us to get the possible value of the x. But here comes the short method of solving this. The first thing to do is we assume a letter equals to the root of 3. Suppose I choose a letter y and I let it to root of 3, and by taking the square of both sides we have y square equals to 3. That is, anywhere I see 3, I will replace it with y square and root 3 with y. Then we have x to the power of 3, and we have 3 here as y square, then replacing it with y square plus this root 3 is y and close by x plus the 3 as well is y square. Everything equals to 0. Let's expand this. We have x to the power of 3, and by expanding this we have minus x. We open this, we have xy square and minus xy plus y square equals to 0. Let's do little expansion here. If you combine this, we can take x out, and since we take s1 out from x raised to the power 3, we are left with s square minus y square. And for this as well, if you take out y, and we have this as x minus y, all equals to 0. The reason I change this to negative is if you multiply this negative through the bracket, you get the result above. And this one is a difference of 2 square, which can be written as x to the power of. This go in two different operations as minus and positive. There we have x minus y and x plus y. So that is difference of 2 square. And y for this minus y bracket x minus y all equals to 0. At these two separate sides, we have x minus y common. So which means if I take out x minus y, I will combine everything in a bracket. Then we have x left bracket x plus y, then negative y. Since I've taken out x minus y, everything equals to 0. All right, let's let this one equals to 0 and this one also equals to 0. By doing that, we have x minus y equals to 0. Then or x to the bracket of x plus y minus y equal to 0. But from what we let above, y equals root 3. So we are going to replace it here. And we have x minus root 3 equals to 0. Which means the x equals to 3. And here is the first solution to the cubic root, the cubic equations. And for this, if you have x squared plus xy, so just by expanding, minus y equals to 0. But y here is root 3. Now let's replace it here. Here we have x squared plus, then we have root 3x minus root 3 equals to 0. This is not easily factorizable since it's a quadratic equation. We are going to apply the quadratic formula to find the true value of x. And x is minus b plus or minus the root of b square minus 4ac divided by 2a. And here is a general quadratic formula where a equals to 1 from the equation above, b equals to root 3, and c is minus root 3. Let's plug in all this value in this formula. Here we have x equals to minus root 3 plus or minus the root of b is root 3 and all square minus 4 dot 1 dot, so let's create bracket for this, and here we have minus root 3 and everything divided by 2a, and a is 1, that is 2 multiplied by 1. Here we have x equals to minus root 3 plus or minus the root of, if square cancel square roots, here we have 3, and minus multiply minus, that is plus, then we have 4 root 3, everything divided by 2. And therefore, we are going to get our x2 equals minus root 3 plus root 3 plus 4 root 3 divided by 2. And the last root is x3, which is equals to minus root 3 minus the root of 3 plus 4 root 3 divided by 2. That is the solution for all the roots. But some might think of, why can't we expand this? Yeah, we can expand this, but I'll just give you the tips on how to go with it. So we are going to let the root of 3 plus 4 root 3 to be any alphabet. Let's say I choose m plus root n. If we apply this, we are going to get the value of m and n, and we plug in it in that equation above. But there is a chance of getting the complex root in this. Alright, thanks for watching. Don't forget the steps I used. Never stop learning. Those who stop learning, stop living.